Traceroute, one of the primary diagnostic tool used in computer networking world. In this lesson, I'm going to explain how Traceroute works, what are the primary use cases for this network utility. Traceroute command is used to identify the network path between two systems. It can be client and server or client to client, from network perspective to identify the path between two nodes in the network. So this utility comes with primarily all operating system include Windows, Linux and Mac. Primary use cases are Traceroute tool used to identify the network path in real time when you troubleshoot path related problems include routing loop and identifying the routing path, or is that the path is correct or wrong, to validate the forward and reverse route. Next one is latency. Identifying latency between network hops is difficult as we don't have control over all network path except source or maybe destination. But identifying path latency, how long the path is taking, is there any route optimization required or not to take such decisions, the latency would be a key resource to take those decisions. So network latency is the second use case. The first one is finding the path. So here the primary key ask here is how Traceroute works. So this utility comes with operating system. So for example, from source left side I just put one Windows host, right side there is a server or host, you consider just a system. So the host, from source, trying to identify the networking path. So in this path I don't know the router IP address in the path, so I want to know what are the path the packet traverse. uh, Basically, Traceroute utilize ICMP to identify the network path. In ICMP, IP header, it sets TTL value 1, 2, 3 in increment order, subset of packets. Then intentionally it going to expires the TTL value. Let's say example, the source trying to find the first hop, which is first router, which sends a packet with TTL value 1. So this packet will not cross the first router because TTL value, as soon as it reaches the router, it go decremental order, TTL value 1 to 0, then it discard the packet and send back the TTL exceeded error message to the source. In this error message, the source IP of the router exists, it used to identify the path. Similar way, identifying the second hop, source sends ICMP request with TTL value 2. So it crosses first router with TTL value 2 to 1, then it reaches second router with TTL value 1, then exceeds TTL value to 0, then the packet get discarded in second router. Router 2 sends the ICMP error message to the source. So this way source identify the second router. This goes up to identify the destination. Up to 30 hops is the maximum limit for Windows. This way you can understand how Traceroute works to identify the path. Now comes to the second one, latency. So to identify each hop, the source sends three set of packets. I mean three set of ICMP packets to the destination with the TTL value in incremental order. So when three packets sent to first router with TTL value 1, all three packets going to expire and discarded, error message sent. So these three responses are recorded in the response. Here you can see the example traceroute response for one of the public IP address. The first column is hop number, second 3, 4. First 2, 3, 4 columns are the time in millisecond for that three set of packets. So if you take first row, the TTL value equal to 1 set and 3 time, I mean 3 packets into the destination, and it expires on first router. Second row, similarly TTL value 2 and expires on second router. So we got the IP address of the second router as well as 3 time the timestamp. I mean the latency it takes to round trip time from source to that second router. So these 3 columns used to identify the time it takes. While troubleshooting, if you see abnormal timings like more than 200 millisecond, like that, that would indicate there would be a problem in that particular hop. Maybe between that hop, we need to investigate. Is there any, issues exist there? The hops you can see 8 and 9, 10 comes with the asterisk star and request timed out. Could be the reason due to um, ICMP echo request and response might be blocked in this network. So this is something happens over the network. Maybe the backbone ISP block those requests traversing in their network. That indicates that would be blocked. But end of the hop, we find the destination. So it able to reach the destination, source to destination in round trip 35 millisecond uh, to reach the destination. If I take this trace route in the PCAP, whatever I explain, you can see in the TTL value. So first 3 set of packets set with TTL value equal to 1 to intentionally expire on the first router. Then TTL value 2 with the 3 packets, it going to expire on second hop. So based on this method, we able to identify the network path and network latency. Hope this video is helpful. Thank you for watching.